Hey again, it's Mrs. Lethe back for video lesson 4 on the kinetic molecular theory, focusing on the gases. So there are 4 assumptions of the kinetic molecular theory as it applies to gases. We're going to take a look at each one of those. The word kinetic, we know, means motion, and the energy an object has because of its motion is called kinetic energy. So according to the kinetic theory, all matter consists of tiny particles that are in constant motion. The particles in a gas are usually molecules or atoms. The kinetic molecular theory as it applies to gases includes 4 assumptions that are very specific for gases. The first one is that particles in a gas are considered to be small, hard spheres with an insignificant volume. And so we see, like in this box here, now we have these little spheres that atoms are considered to be, and they're pretty far apart, spaced far apart, and so the volume, their size is pretty negligible. Some other assumptions that we have is that within the gas, the particles are relatively far apart compared with the distance between particles in a liquid or solid, and between the particles there is empty space. The key thing here is that there are no attractive or repulsive forces that exist between the particles in a gas. The second assumption is that the motion of particles in a gas is rapid, constant, and random. And because of their motion, the gases are able to fill up their containers regardless of the shape or the volume of the container. So they're constantly moving rapidly in this constant straight line but a random motion. But if you had an uncontained gas, let's say that this box was open, then the gas can spread out and mix with the particles of its environment without any kind of limits. And that spreading out, spontaneous spreading and mixing with particles in the environment is called diffusion. Third, also deals with the motion of particles in a gas being rapid, constant, and random. These particles, it causes them to collide with one another and with the walls of the containers. We can see that in here. And these collisions is what actually makes up gas pressure. All collisions, and this is the last assumption, all collisions between particles in a gas are what we call elastic. And I don't mean elastic like a rubber band is elastic. What this means is that during elastic collisions, the kinetic energy, that is the energy of motion between these particles, is transferred from one to another. So if they're moving with a certain amount of speed, the energy when they collide is transferred from one particle to another without any energy being lost. So the total kinetic energy remains constant, and that is what we call elastic collisions. So if you describe an elastic collision between gas molecules, we would say that an elastic collision is one in which kinetic energy is transferred from one particle to another with no overloss of the kinetic energy. And with that ends video lesson number 4, and like the previous ones, be happy, have fun, and dance. This is Mrs. Lethe, so long for now.